Hello everyone, my name is Pritam Paul and welcome to another video of my C programming playlist. In the last video, we have talked about the switch case problems. We have solved those problems and the codes are in the description. Okay. And if you're new to the channel, please do hit the subscribe button and press the bell icon so that every video could be reached to you through notification. So let's start. So before going to start, let me tell you that I've already discussed about the for loop concept and how it works and few examples as well. If you want to know, then you need to go to that video. The link will be in the description or in the I button. Do check it out and watch those videos. And if you know already, and if you want to solve these problems, then you can watch this. But before watching this video, I would advise you to go to my problem sheet, which will be, the link will be in the description. Just go to that sheet first and try to solve those problems, and if you are unable to solve, then you can watch this. And if you are already done with these problems, then congratulations, you can check it out for you, for the betterment of the codes and the betterment of the concepts. And if you are sure that you can do it by your own and you are confident, then you can skip this video and you can go to the next video. Okay, so let's start. So this is the problem one. Write a program to print any name for 10 times. So we all know that iterative statements are being used, okay, for printing, for doing the same work, okay, many times. So here, what is the work? The work is the printing the name, okay. For example, my name, okay. So if I take for int I equal to 0 and I less than 10 and then I plus plus, and then if I write printf Pritam Paul backslash n, okay, and then so here you can see I have printed out the name for 10 times. Okay, so if you want to add a serial, then you can write %d dot, and then you can write I plus 1 because I am starting from 0 now. So here you can see 1 to 10. See? Yeah. So now let's go to the second problem. Write a program to print all the 2-digit odd numbers in reverse order. So 2-digit odd numbers in reverse order. So 2-digit odd number is 99 and up to all the 2-digit odd number, that means 11. 99 to 11. Then I can say, second, let me copy here. It will save a lot of time. Okay. So for I equal to 99 and then I greater than 10. Okay, and I say I minus equal to 2. So we will be, if we decrease the I value by 2, then 99, 97, 95, 93, in this way it will come. Na? And then if I print %d comma, okay, I. So yeah, you can see 99 to 11, all the 2-digit odd numbers in reverse order. Okay, now write a program to input n and find the sum of n natural numbers. Okay, so using for loop, we can do without using for loop as well, but let me do it by for loop first. So at first you need to take the input of n, and after that, okay, I need to declare it also. Sorry. Yeah. So integer n, then you have to take the input and then sum equal to 0. Then for I equal to 1, I less than n, I plus plus sum plus or equal to I. So for example, n equal to 5. Okay. Then s equal to 0. Then sum equal to I equal to 0. Then sum equal to what? Sum equal to would be 0. Okay. Then I equal to, I equal to 1. Then sum would be equal to 1. 0 plus 1. And then sum plus equal to I. Sum plus equal to I means sum equal to sum plus I. Now I equal to 2, sum equal to 1. 2 plus 1 is 3, the sum equal to 3. Then 3 plus 3 would be 6. 6 plus 4 would be 10. Then 10 plus 5 would be 15. The ultimate result is 15. See? 15. For example, if I press 10, then 55. In this way, you can do it. It's very easy. Okay. Now, problem 4. Write a program to input any number and find the factorial of that number using for loop. For what is factorial? Factorial is what? For example, 5 factorial equal to 5 into 4 into 3 into 2 into 1. Okay. That means if I press n, then I have to find the multiplication from 1 to n. Some we know how to do multiplication. The operator would be changed. That's it. Okay. Now, see, 120 is the factorial. Okay. For example, if I write 12, then you can see 47900. Okay. And if I write, for example, 25, you can see, you can like 31 also, we can have the factorial. Okay. So in this way, you can find the factorial. Just there would be an asterisk because in the previous program, we have done the summation, sum of n natural number. So factorial means multiplication from 1 to n. Obviously, then that's the thing. And here why I have taken the unsigned long n, because the range, okay, the range would be much more higher if I talk about the multiplication. For example, a factorial of 25, as you guys can see. For example, factorial of 25. This number is obviously not in the range of the integer in C, isn't it? And that's why we need to use unsigned long end. Okay, that's why. Write a program to multiply two positive numbers without using asterisk operator. That means, for example, if I write 3 and 4, I would have the output 12. So now we need to understand that what is 3 multiplication 4? It means 3 plus 3 plus 3 plus 3, or I can say 4 plus 4 plus 4. That means x and y, that is you need to sum, okay, x y times or sum y x times. Okay, so that's it. So so here this is the code. You can see 3 and 4, the 12 is the answer. Okay, 5 and 7, 35 is the answer. So in this program, I have taken sum equal to 0. In this program, I have taken f equal to 1. In this program, I have taken answer equal to 0. So why 0 and why 1? That's a valid question you need to have in your brain. Yeah. So in this program, we are doing the plus operation. Here also we are doing the plus operation. So we are doing actually addition. So what is the additive identity? It is 0. In mathematics, we have learned it. And what is the multiplicative identity, which is 1? That's why there we have taken 1, and here I have taken 0, because when we will be doing the first operation, which is sum equal to sum plus I. So this sum, what would be the value of that if you don't put any value here? That's why I got error in this code. Okay, when I didn't initialize it as 0. See here, if I put 3 and 4, see the answer is 419444. Yeah, so you need to put obviously 0 here. Okay, and then you can see the output would be 12. That's how it happens. Now 6. Write a program to input an integer and find out the sum of all the digits of that number using for loop. Now how we can do that? Okay, for example, 1 2 3 4. Then what would be the result? The result would be 4 plus 3 is 7, 7 plus 2, 9, and 10. 10 the answer. Now how can we do that? If we take sum equal to 0, okay, and then if we do sum plus equal to the digit का sum चाहिए ना? Yeah. So how to find the digit? Obviously, if the number n equal to 1 2 3 4, And if I do n modulus 10, what would be the value of the n modulus 10? N modulus 10 would be used to be the 4, obviously. 4 would be the rightmost digit. Okay. Rightmost digit. And then if I do n equal to n divided by 10, then what would be the value? The value would be 1 to 3, obviously. Yeah. 1, 2, 3, 4 divided by 10 would be 1 to 3, obviously. Yeah, due to the type conversion and all. Yeah. So yeah, this is the algorithm. Now, up to when we have to do this? We have to do this until the n becomes 0. So hash include stdio.h. It is a main. It is a n. The initialization part has been done. Actually, this problem should be done by while loop, but I'm using for loop here. When the while loop portion will come, or in this topic also, I can show the while loop as well. That doesn't matter. Okay, so the initialization part is done, and then the limit would be n greater than 0, and the decrement operator n divide equal to 10. Yeah. Now integer d equal to n modulus 10, integer sum equal to 0, then sum plus or equal to d. So okay, so here you can see the digits of 0 it's coming. So that's why we are going to take like x equal to n, and here we are going to put x. Okay, I'm just taking a copy of n and to print it out. If you do not want to print it, then do not need to store the copy and all. So you can see 10 is the result. Now problem 7. Write a program to input a number and count the number of digits using for loop. Count the number of digits. So here we are adding actually, the whole program will be same. Just we have to take a count variable to count it. Okay. So here integer n, and then here we are going to write count equal to 0 and count plus. That's all. Okay, some error is there, I guess. Okay, I will give a semicolon. See, 5, 6. Yeah, in this way you can do it. Now, problem 8. Write a program to input lower limit and upper limit and print all the numbers in that range. So, what we are going to do is, okay, we are going to lower limit and upper limit, LL and UL. Now, printf okay, so print all the odd numbers in that range. Okay. Odd numbers, then if I modulus 2 will equal 1 percent. Yeah. So I modulus 2 will equal 1. So yeah, that's it. 0. So 1 to 999. All the odd numbers are there. Okay. So now the problem 9, which is write a program to input a number and print the multiplication table of each number. Okay. So here I have taken an integer, taken the input also. Now the multiplication table from 1 to 10, obviously we all know that I equal to 1 and I less than 11 and I plus plus. Now, obviously printf, so I am taking the output. Okay, I'm just writing the output in such a way that we can have a beautiful representation. That's why percent d into percent d equal to percent d. So for example, 9 into 1 equal to 9, 9 into 2 equal to 18. So 9, 1 and 9, 9, 2, 18, 9, 3, 27. That's all. The expression also there. Let's try it. For example, 9. You see, 9 into 1 equal to 9, 9 equal to 18, 9 equal to 27, 36, 45, 54, 63, 72, 81, 90. That's all. Now, if you want to, this is a multiplication table by default. If you want to take it up to 20, it's up to you. Okay. It's up to you. So that's how the things are. No problem then. Write a program to input a number and print 20 numbers in descending order from that number. Okay. So hash include stdio.h. So see 20 to 1, 20 descending number. Okay, for example, 100, 100 to 81. For example, 34, 34 to 15. In this way, you can print I equal to n, I greater than n minus 20, 20 up to 20 descending number, no? And then I minus minus, that's it. That's a very simple code. Now, problem number 11. Write a program to calculate x to the power y using library function. Okay, so library function is what? Like by default, there are a few functions by which you can do a lot of work. Like x to the power y, the by default function is actually power x comma y. Power x comma y will return x to the power y value. But here we can't use the power. We have to do it raw. The x to the power y means what? X to the power y means x, for example, x into x. Okay, in sorry, x into x up to y times. For example, 2 to the power 5 is equal to what? Equal to 2 asterisk 2 asterisk 2 asterisk 2 asterisk 2. Yeah. So there are 5 times we have to do the multiplication. Okay. So hash include stdio.h and integer main. So here we are going to multiplication. That's why I've taken 1. Oh, I haven't printed out the result. So 32 is the answer. So 4 and 4, 2, 5, 6, 2 to the power 10, 1024. In this way, we can do it. Yeah. Now, problem number 12. Write a program to input any number and print and find the factors. Okay. Find the factors of that number using for loop. Okay. So, how to find the factors actually? Factors means what? For example, if I press n, then from 1 to n, if any number would be divided by n, then that is the factor. So we have to run a for loop. Okay, first of all, let us take an input of that number. Okay, now these are I equal to 1, not I equal to 0. Because 0 divided by 0 would be infinity and the program will not be running up. So I equal to 1, I lesser equal to n, I plus plus, if n modulus I equal 0. If n modulus I equal 0, that means I would n is divided by I. Okay, so we are going to print I percentage backslash t comma I. Okay, before that, let's print backslash n. So person B are 12, 1, 2, 3, 4, 6, 12. Example, 800. So 1, 2, 4, 5, 8, 10, 16, 20, 25, 32, 40, 50, 80, 100, 160, 200, 400, 800. So in this way, you can find the factors. Okay. Now, as we all know how to find the factor, from 1 to 1, we have to run a loop. And if I is divided by n, then I is the factor, obviously. That's the simple logic. Write a program to input a number and check if it is perfect or not. Okay. Perfect is what? Factors summation. Okay. Factors summation would be the same of that number. For example, obviously 6. For example, 1, 2, 3. So 6 we will avoid, obviously. 1, 2, 3. What is the summation? 6. Then 6 is a perfect number. In this way, let's code it and you will understand. Now, what we are going to do, we have to do sum equal to 0 and also copy of now factors sum now. So for I equal to 1, I less or equal to n. Oh, I less than n, sorry, I plus plus. So here we do not need copy of n. I'm sorry. If would be needed, then we'll be taking it later. So 0 I equal to 1, I less than n, I plus plus. Okay. If n modulus I equal 0, then sum plus equal to I. So how here what we are doing, if n modulus are equal 0, that means I is a factor. If I is a factor, we are going to sum it. Okay, we are taking the sum again and again. Okay, so if the sum equal n, then printf percentage is a perfect number, comma n. Else printf percentage is not a perfect number. Okay, is not a perfect number. Okay, it's not a perfect number. Now let's run it first. 6 is a perfect number, and 12 is not a perfect number. Why? Because 12 is 1, 2, 3, 4, 6. So all the summations will not be equal to 12. But in case of 6, 1, 2, 3, which is be summing 6. That's why it's a perfect number. Now here we can do one thing. So how I am commenting? Alt Shift A. Okay, Alt Shift A. So if I write sum equal n conditional operator, this one, okay, or this one. So this also is going to, what is this actually? This is conditional operator. We have learned about it, right? So 6, perfect number. 14, not a perfect number. Okay. So Control L to clear the terminal screen. Okay. So in this way, you can find it out. That's very easy. Now write a program to input a number and check either it is a strong number or not. Now digits factorial sum is equal to that number or not. Okay, using for loop. So digits factorial sum. Okay, so hash load dot h main integer n now we have taken the input, obviously. Okay, digits factorial sum. digits factorial sum. So sum equal to 0. Okay. And digit, that means n will be manipulated. So copy of n equal to n. That's fine. For we can use only for loop. So actually ideally I should use while loop here, but I'm not, because it's a for loop problem. So that's why I'm doing it in for loop. But when we will be completing all the loops, all the control statements, and we will be going to the lead code to solve few problems, there we will be using while loop for this kind of problems. So it would you need to understand which loop will be beneficiary to use, which loop would be very easy to use here, which would be very much appropriate here. You will be understanding it after few lectures, and don't worry. But for now, use for loop, because I have shown you guys how to use for loop here. Integer d equal to n modulus 10, and now so integer d equal to n modulus 10, and now we need to find the factorial. Okay, so a digits factorial will not be exceeding the integer limit. That's why we are taking fact equal to 1 here. Okay, and now for integer I equal to 1, I less or equal to d, I plus plus fact asterisk equal to I. Okay, and now printf %d. Okay, once again, why I'm printing factorial sum, बोला ना, तो sum plus equal to fact. Now enter a number, for example 145. So 145 is a strong number. How is a factorial? So 1 factorial is 1, 5 factorial is 120, so it's 121 plus obviously factorial 4. So factorial 4 would be 4 into 3. 4 into 3 is 12, 12 into 20 is 24. So all equal to 145. That's how it is 145. If I put 153, then you can see that 153 is not a strong number. So this is the way you can find out the strong number. Okay. Now write a program to input a number and find the count the number of factors. It's very easy. If I can find the factors, then obviously I can find the number of factors as well. Okay. So this line needed. So count equal to 0, and if I get any factor, then I'm increasing the count. So printf six, 1, 2, 3, 4, 6, 12. So 6. Okay. So in this way you can do. Now prime or not. So count the number of factors we are able to find. So if we get the count equal to, then we can say it's a prime number. Okay. Count equal to, so then printf not a prime number. Okay. For example, 7 prime number, 4 not a prime number. So in this you can find the prime number as well. Now problem number 17. So what is Armstrong number here? Armstrong number is like if there is a 3-digit number, for example, if there is a 3-digit number, for example, 371 will be equal to, add the number of digits are 3, then obviously we have to do like that. So 3 caret 3 plus 3 to the power 7 plus, sorry, 7 to the power 3 and to the power 3, and then 1 to the power 3. So 3 to the power 3, which is 27, plus 7 to the power 3, which is 370, plus 1 would be 371. That is the calculation. Okay. Now, how we can do that? First of all, we need to find out how many number of digits are there. Okay. So dottage. You have taken the input. Okay. Now we need to find the digits. Okay. So for that, first of all, integer sum equal to 0 and copy of n equal to n. Now for n greater than 0 and divide it to 10. Okay. Now integer d equal to integer, okay. Count equal to 0. We need to find the count now. So count plus plus. Okay. Now if you take another copy. Okay. Now we have count, find out the count. Now what we need to do is we need to for copy of n greater than 0 and then copy of n divide equal to 10. Okay. Now what we need to do, we need to like integer d equal to copy of n modulus 10. Now we need to do like sum plus or equal to pow d comma count. So for pow we need to add math.h. So I have told you guys how to implement the pow, isn't it? Now if sum equal copy of n, then printf Armstrong number else printf not an Armstrong number. Return 0. So let's run. So 371 Armstrong number. Correct? 4, 5, 6, 7. Not an Armstrong number. Okay. So in this way, you can find the Armstrong numbers. Okay. Here we are doing count the number of digits, and then we are going to check the either it is find the sum, and then we will be checking either it is Armstrong number or not. Okay. So in this section we have done the count the number of digits. Okay. For example, in the example here I have shown you guys, like for example 371, that would be 3 cube plus 7 cube plus 1 cube, isn't it? So we are doing the same thing. So we don't know now how many number of digits are there in the given number. Okay. So that's why we have to take the count first. Okay. And then we are going to add them. Okay. And pow, obviously I have told you guys, pow will return x to the power y. Obviously pow x comma y equal to x to the power y. Okay. So that's why D to the power count, digit to the power count the number of digits, isn't it? So in this way, we are going to add them, and then at the last, we are going to check. Okay. The 18th problem. Write a program to print the Fibonacci series up to nth term. Okay. So now what is Fibonacci series? Fibonacci series starts from 1, or you can say start from 0 as well. It is doubt. Actually, it's a matter of debate. It's a debatable that it start by 0 or 1. Let's consider. I'm not going into any controversy. Let's consider it's 1, and the second element is 1. Now the third element would be 1, 1, 2. The fourth element would be 2 plus 1, 3. The 2 plus 3, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, then 34, and then 55, I guess, 4 plus 1, 5, plus 5, then I guess 89. So in this way, it is heading up. Okay. So we have to find, okay, up to nth term. Okay. Nth term, and in the next problem is up to n. Print the Fibonacci is up to n. So nth term means what? If you enter 10, so up to 10th term, you need to print out the Fibonacci series. Okay. So stdio.h. Now integer first equal to 1, second equal to 1 for so first and second element has been printed out. Now I need to do I equal to 1 and I equal to 2 is done. So I equal to 3, I less or equal to n, then I plus plus. Okay. So integer sum equal to first plus second, and then print percentage x plus t comma sum, and then what would be the what would be the sum equal, sorry, what would be the second would be equal to sum, and oh sorry, integer I equal to 3. Okay. So now we have we have done 1 and 2 and the sum. Now the first will be the second one, and the sum would be the second, like I mean second equal to, okay, so first equal to second, and then second equal to sum. Yeah. And then finally return 0. Yeah. So enter a number 5. So you can see, oh my god, कुछ गड़बड़ हुआ है. Let's see, first equal to 1, second equal to 1. Oh, no, 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 everything is fine, everything is fine. Okay, there will be a backslash t, and now, yeah, so if I take 5, so 1, 1, 2, 3, 5, you can see. Now if I run again, 15, so you can see 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 numbers has been printed. Yeah. Now let's just copy and go to the next problem, which is up to n. Okay. So here the calculation would be different. We are not going like this. So integer I equal to now 1. Okay. And we are not printing here like this. Second less than or equal to n. Okay. And let's leave it. Sum equal to first plus second. Okay. Yeah. First and second have been printed out. Sum equal to first plus second. and then print a percentage sum, and then first equal to 7, second equal to sum. Okay, yeah, that's it, guys. And then let's print it. So 1000. So you can see, okay. So here you can see 1000. Yeah, now it is okay. You have to check before printing. And the second value is getting the higher version, higher value. Na? So that's why we are checking the second lesser equal to n. We have to check up to n, isn't it? That's how. Exactly the same problem. Here just the condition is different. That's it. In the previous program, we have taken the I equal to 3, I lesser equal to n. I equal to 1, I equal to 2, that has been printed out here. And then 3 to n. That's simple. But here, this is not the same one. In this case, the second has to be, or you can take the sum as well. Sum has to be less or equal to n. Okay. If it is n, then we are going to take the whole thing. Yeah. So that's how second less or equal to n, because second is getting the value sum. And before printing, we have to check either sum less or equal to n or not. If it is less or equal to n, then we are going to print it. Otherwise, it is not going to be printed, and some second is getting updated, and there that would not be satisfying, and the for loop will break down. Okay. For example, if I put 2000, so you can see 157 plus this one will cross the 2000 value. That's why the next value is not getting printed. It's very simple. Okay. Now last problem, which is write a program to input a number and check whether it is palindrome or not. Palindrome number is what? Palindrome number is like, for example, 1 to 1, 1 to 3 to 1, or 1 double to 1, or 1 2 3 3 4 4 3 3 2 1. These are the things. That means from left side to right side, if the number is same, for example, like 1 to 3. So the reverse of this number is 3 to 1. So both of them are not same. That's why 1 to 3 is not a palindrome number. Palindrome string also could be there. When we will be discussing about string and arrays, we will be doing problems on palindrome and all. So that's why you need to understand this. Yeah. So integer main, integer n, yeah. Now reverse of n, okay, equal to 0, and also copy of n equal to n. Okay. Now for, okay, n greater than 0, n divide equal to 10. Okay. And now what we are going to do is reverse of n plus or equal to, okay, equal to reverse of n into 10 plus n modulus 10. The digit is going to be printed. So I will show you, don't worry. Yeah. That's how it is. And now if reverse of n is equal copy of n, then sorry, not return, like printf palindrome, else printf not a palindrome. Okay, then return 0. Okay, so now let's check first of all either the code is working or not. Palindrome, okay, not a palindrome. Okay, so how it is working? So reverse of n, in this number we are storing the reverse of the given number. Okay, and copy of n, obviously the n will be affected when we will be manipulating the digits and all. So how this is working? For example, the n is 1 to 1. So copy of n would be like obviously 1 to 1, but the reverse of n is 0. Okay. Now here n modulus 10 is what? 1. Reverse of n equal to reverse of n into 10 plus 1. So 0 into 10 plus 1, which is 1. Then it's going like that. Now the n value is 12. Now 12 is modulus 10 is 2. So reverse of n is 1. 1 into 10 is 10 plus 2, which is 12. Now again, n modulus 10 means 1, isn't it? So reverse of n in 12, 12 into 10 is 120. 120 plus 1 is 121. In this way, we are storing the reverse number. Okay, so in this way we can do all the problems, and many of these problems, like all the digits and all, means in the problems where you need to find the digit, you need to work on the digit and all. So there basically we use while loop, we do not use for loop. But here I have shown you how to use for loop. You need to know every single thing in a language. That's why I'm showing. Okay, so this is a very long video, 20 problems. And thank you so much for watching this video. I hope this video is going to be very helpful who are completely beginners, who don't know anything. So these are the very few common problems you need to know by all these things. Why I'm actually giving them in the problem sheet, because when you will be doing this kind of problems, your brain will be open up for the programming and all. You will be understanding how the things are happening and all. That's why I have given all these problems and try to practice them and try to understand them. Okay. And another thing is try to solve them without watching the solutions. For example, you have watched the solutions first, and after that try just take a break for, I guess, 1 day, and then in the next day you try these problems by your own. If you can't solve, then watch and then take a break of 1 day, and then or 12 hours or 6 hours, and then try to solve them. Try to practice them so that you could be understanding these problems. As you are a complete beginner, this is going to be very hard to keep everything in your brain by a single amount of practice. So that's why I suggest you to practice a lot of times. Okay, lot of practices are needed to brush up your mind. Okay, so this much for today. And guys, if you are new, I'm telling again and again, please do hit the subscribe button, because your subscriptions really encourage me to write down all these scripts and all these codes, and to make a lot of contents for you guys. Thank you so much, and thanks for your support, who are sharing, who are supporting the channel. I'm really grateful to all of you. Keep doing supporting, and keep coding. Yeah, thank you so much. This much for today, and see you in the next video.